and final talk for today. So big congrats for everyone sticking up till the end. I know it's been long 2 days, but we kept a super interesting lecture for the end. Today we have Carlos Salas from NordLayer or Nord Security. So some of you may be familiar with one of Nord Security's brand, NordVPN. This is not, so he's not working in that vertical, but for the same company. Carlos has a black belt in Taekwondo, so don't mess with him, first of all. He fell in love with engineering since he was 4 with the first Nintendo he got. Was it Mario, the thing that got you hooked, or something else? Mario, usually that happens. And he has written a poetry book, and in general kind of enjoys and learns enjoys to learn about technology, and is often a speaker and speaker on multiple podcasts. So today he will be speaking about how to keep your organization safe with zero trust network access. In general, we'll hopefully learn some best practices and how to stay secure. The pandemic had a huge increase in the overall number of attacks that happened, so it kind of shifted the way cybersecurity was looked at from the organization. And now when the dust has a little bit settled, now we kind of have to establish new rules and how things work from the cybersecurity perspective. So Carlos, without further ado, please join.
Thank you. So, yeah, as you already heard, my name is Carlos Salas. I work as an engineer. I was engineering manager. Now I'm head of engineering at NordLayer, part of Nord Security. Practically, it's NordVPN, but for businesses with a more business-oriented cybersecurity solutions. And today I'm going to talk about what is zero trust network access, how do you use it, how do you eat it. So for just to know, anyone has heard about zero trust of any kind, zero trust architecture, zero trust network access? Few people, okay. For the people that don't know what zero trust network access is, I will first need to start by talking where did it come from. Zero trust network access came from one of our favorite sources of information when we are talking about policies and so on, Gartner. And well, I say favorite, kind of like and not in a very good way, because most of the time when we're talking about Gartner, it's very complex what they are trying to implement. It's very academic-wise, academic forward. You need to read lots of white papers, you need to be part of their network, and sometimes, most of the time actually, what comes from Gartner, they're actually very good things coming from them. The bad thing about this is that there's a lot of companies that take whatever they are publishing and start creating publicity, marketing strategies around it. And some of those marketing strategies might rest importance to the main framework that they are actually pushing, in this case, zero trust. Normally, I will compare it to, for example, in the 90s. I don't know if some of you remember 90s, early 2000s, when we had, for example, the word cyber, the prefix cyber. Cyber was everywhere. I remember when I was a kid, I had some cyber shoes. Practically, they were shoes that would light up every time I take a step. And everything was cyber, cyber, cyber everywhere. And this was kind of funny on one side, but kind of bad on the other side, because some companies were like, okay, cyber, whatever cyber is just a trend, is just a marketing strategy. marketing BS. So I'm not going to invest into this, what is called? Cybersecurity? Whatever. No, this is not for me. And one of the most prolific hackings of the 80s and 90s happened because of this type of situations. Well, in order to know more about what Zero Trust Network Access is, practically you could boil it down to trust no one. You can't trust anyone that is happening, anything that is happening on your network. I like to put it in a very interesting way. For example, something that happens to me every time I travel. That happened to me when I was coming to Serbia. I'm living right now in Lithuania, so I had to go through Istanbul and then to Belgrade. So when I got to Istanbul, when I tried to board the plane, there was a police officer saying, "Okay, you come over. What's your name?" "No, my name is Carlos Salas." "Perfect. Passport." "Okay, here you go." "I don't trust you." "Other document." "Okay, here's another document." Then back and forth, pictures, me. No. "Okay, how about this?" And then he started asking me, "Así que eres de México?" In English. "So you are from Mexico?" So like, sí, soy de México. "I'm from Mexico." "Oh, okay, cool. Yeah, thanks." So he actually had to validate for multiple steps that I was actually who I was telling I was. If we translate this into the network, into the cybersecurity environment, we can put it in the same way. Firewalls were working in a similar way on this. Where are you coming from? Where are you going? And what type of data you are. But this is very basic, and it's not enough for the modern cybersecurity environment. So little by little, some extra steps has been taken in order to prove that you can actually protect yourself. And everything boils down to the fact that the internet by itself, by design, is not secure. If you install anything out of the box that is connected to the internet, it's insecure by default. And this is by design, this is not a bug. And we are going to talk a little bit about this later on the presentation. So who am I, first of all? Well, yes, I'm a Taekwondo second dan black belt. I'm a writer. I'm also an R&D engineer. I'm the one that is pushing the R&D developments on Nord Layer. And I also manage all that has to do with the platform. Anything that has to do with VPN servers, firewalls, apps, and so on and so forth. And on my free time, I also like doing mountaineering, especially free climbing, which is practically climbing without any type of safety stuff. So I'm actually surprised that I'm still alive. Anyway, so we are going to talk about what was happening in the beginning. So in the beginning, when everything started to come from the university's research, sometimes some researcher, let's say that the MIT in Massachusetts, was trying to send some data or was trying to use some resources that UCLA had in California. So what they could do, well, they will need to send some researchers to fly to California and back if they wanted to use their network, if they wanted to use their supercomputers, or if they wanted to share some research. But then a few groups of computer science researchers decide, like, okay, but what if we connect our network to their network? Well, that sounds actually quite good, quite nice. So they decided to start interconnecting their networks. So in this case, they had a single entry-exit point. They had practically, it was a huge local area network, a huge LAN in terms of how it was this working. And because of this is how it's working, they were able to reach any destination. If they wanted to reach from one computer to the other, from one server to the other, everything was open. Because that was the nature of this tool. They wanted to be able to reach their file systems from one side to the other and to be able to copy their data from one point to the other, to be able to read, to write, to delete everywhere. And that's the design, how it was designed. And because of it, the root of all cybersecurity issues is that the internet was never meant to be secure. The internet was created to be able to be accessed by a selected few, let's say maybe maximum 100 people at any given moment. But then they created this net, it was called ARPANET. Then the United States military said, I think it's actually a quite good idea. I want to also interconnect my military bases, so they created MILNET. With MILNET, as everybody knows, most of the new improvements of life that we have, not only on the cybersecurity perspective, but in general, came from military budget, military research. Velcro is one of them. Teflon, the ones that we have in our pants, is also one of them. And the internet is one of them. But because that was the issue, I mean, 20 people working at the same time, it's like imagine that you are in a room with 20 people and someone sneezes. Even if you are on the other side of the room, if you turn around and say, hey, who sneezed? Even if that person doesn't say anything, the people around will say, what's this guy? Okay, bless you. Okay, that's it. But now imagine that you are in a country with 3 million people and someone in a very remote location sneezes. You will never know that that happened. And that's the nature of the internet right now. There are so many people, and it's hard to track who is doing what, especially because actually a few years ago, the internet started running out of IP addresses, IPv4. We managed to go around it by creating network address translator, NAT. So in this case, for example, if we are in an office with a single exit point, a single IP that is going outside with 100 people inside, it's going to be very hard for the people outside to know who started creating a single packet that is going outside. So that's one of the main reasons that is so hard to know what's going on there. And that's also the reason that we can't trust anyone, because you can impersonate anything at any moment. So this brings me back to cybersecurity. Cybersecurity is a very diverse and very wide topic. But I always like to separate cybersecurity in 3 main pillars. Prevention side. Of course, everything you should have cybersecurity measures. You most probably in all of your computers have antivirus. You have firewalls that come with your computer. Most of the default restrictions that, for example, any router that is consumer grade comes, it's already fairly safe. Of course, you need to change passwords and so on, but it's fairly well configured in most cases. So in this case, this is quite well. But something that is very important and most people already started to forget is physical security measures. No matter if you have a state-of-the-art firewall, no matter if you have a state-of-the-art intrusion detection systems, or that you have secure gateways to go in and out of your network, if I just come over with the laptop and say, hey, what's up? What's up? And I go to your server room, I connect directly and steal data from you, and you will never know. So that's one of the main reasons that you need to keep physical security also in mind. Identity and access management also. Okay, you want to get into my network? Great. Who are you? Okay, you are Carlos Salas. Perfect. Where do you want to go? I want to go to the HR servers. No, can do. You are a developer. You are going to go to the development servers, and that's it. You need to manage the access, not only the identity. Network segmentation, of course. Now that we have seen a lot of ransomware attacks, we need to make sure that if I get attacked by a ransomware malware, it's not spread into the whole network. It needs to be controlled. It needs to be, the blast radius needs to be small. We need to do a segmentation of the network. I should never be able to reach everything in a network. And of course, as always, the best solution that you can have for prevention is patching and updates. Never be like, okay, it's going to take half an hour to update. I'm not going to do it for a month. Because there could be a 0-day vulnerability that might put you and your organization at risk. Then we have detection. Okay, you couldn't prevent what happened inside of your network. Well, at least you need to know that someone got through your controls. So we have intrusion detection systems that are based on patterns and policies. So for example, if there's a pattern of me always working from Vilnius, and suddenly I appear in Singapore, that's wrong, and I should be blocked from that. Also, if my pattern is I'm working from 9 to 6, from Monday to Friday, and suddenly I connect on Sunday at 3 a.m., it should raise an alarm. And of course, policies everywhere. You can't connect from here, you can't connect from there, you can only access these resources at this time, and so forth and so on. And finally, the most expensive one, remediation. You couldn't prevent a cybersecurity issue. You didn't detect that they were there. Now you have to remediate it. The bad thing here about remediation is that sometimes this is already too late, especially for small to medium businesses. Once you get to the remediation side, it might mean the end of your company, because you might try to fix everything, to close all the holes that these attackers used to get in, but on the public relations side, on the trust that your users will have, that's gone. And the less clients you have, the less income you have, the less people that you can pay, and it goes down from there. So the cheapest and most trustworthy way of keeping your company safe is prevention. If not, ask Uber that they were hacked last year and this year by using the same vulnerability. So not only you have to have good backup policies. In this case, for example, you need to have immutable backups, which means that no matter if you are attacked by a ransomware malware, because it is immutable, you can't even encrypt it. It's not going to go anywhere. You can delete it, you can do anything with it. So that's one of the best cases that you can use. And of course, you need to have very well documented and very well structured post-mortem procedures. You need to know exactly what happened, when it happened, why it happened, in order for it to not to happen again. So let's talk about cybersecurity today. First, let's go with the nice things. I mean, on one hand, we have 1.17 billion active websites as today, with almost 250,000 websites going online every single day. With 5 billion active users, this doesn't mean people. It's people, it's IoT devices, it's any type of device that will connect to the internet at any given moment. I mean, for example, right now I have 2 computers and 2 phones here, so I have 4 users with me. And online retail, of course, more than half of these 1.17 billion active websites, it's related to retail, Amazon, Ali, and of course, some other smaller companies. It's $3.5 trillion US dollars. It's a lot of money. And of course, where there's money, there's a lot of people trying to get advantage of this money. So we have, on the other hand, almost 500,000 new malicious software, some new malware created every single day. This can come in the sense of remote access tools, famous rats, Trojans, as people call it also. It can be also adware, spyware, ransomware, and so on and so forth. And we have also around 2,000 data breaches each year that we know of. And this is very important because we also have 300 million ransomware attacks each year. And most of the time, when we have ransomware attacks, we also have data breaches. So 300 million against 2,000 doesn't make a lot of sense. The thing is that most probably you still don't know that your data is out there. So, well, from here, who has the benefit of working remotely or on a hybrid way? I will guess, yeah, most people, yeah? And I guess you probably love working remotely. And well, the data, it's on your favor. We can see that less than half of the companies in the world that were researched for this are on-site only. And most of them, it's because they are manufacturing companies. I mean, if you're going to build a car, you can't take pieces to your house, build it, and then bring it back to home, so to the office. It makes no sense. So it makes full sense that they are on-site. And there's, of course, some people that are kind of like going against the current, trying to get people to come back to the office. But if we see on this other side, 77% of employees feel that they are more productive at home. 85% of the managers, me included, think that working remotely or working on a hybrid way is the new normal. It won't go anywhere. And 74% of employees believe that if they have this benefit, it's less likely that they will leave the organization. And as far as we have seen in cases like Microsoft, like Apple, there has been few big exodus of people when they are hey, come back to the office. No. And if you make me go, I will go away because I already have 10 prospects now. So this will happen more and more the more we go in the future, or at least that's what I think. And well, with every benefit, there comes a risk, especially if you don't know how to implement remote working. And this happened when the pandemic struck. Most of our companies, especially big companies, were on-premise only, on-site only. So suddenly, from one day to the other, the government came over and said, hey, everyone at home. Hey, but no, I don't care. You go to home. So companies had two different options there. They could either say, okay, you know what, let's bite the bullet, let's not work for the next few months. I won't going to still pay you and everything is fine. Of course, that's not going to help in any way to the company or to the investors. So they decided to, okay, you can work from home, but we are not prepared for that. So these huge cybersecurity policies that we created over the years to make our companies safe with you working inside, we need to throw it away. Because the main reason that it was like this is no one gets in, no one gets out. Now everyone needs to get in and a lot of data needs to go out. So people start making small holes in cybersecurity here and there. So the area of attack that you had at the beginning, only one single entry and exit point with a super fancy firewall, doesn't matter anymore. You start making small holes in your legacy networks that were not prepared to be accessed from the outside. They were not segmented. They were not prepared for that. And also, that's one of the main reasons that during the pandemic, a lot of cyber attacks started appearing here and there. Well, because this was happening. Of course, you are expanding your perimeters before you have very small perimeters. And the more you expand it, the less control you have over them. And of course, legacy policies are not compatible with working from home or working remotely. You need to create new policies or start implementing new policies. And this is where Zero Trust Network Access comes. So in this case, for example, me, a user, want to connect to a network. So the network will ask me before even going inside of the perimeter, how do I know you are who you are? Hey, I'm Carlos Salas. No, I don't trust you. Well, this is my user, this is my password. That's good enough, no? No, that's not good enough because maybe you hacked this guy and maybe you got his credentials from a data leak somewhere else. So multi-factor authentication. You can use your phone, you can use a cryptographic key. Well, okay, fine, I trust you. But where you are right now? Well, you're in Vilnius. Okay, yeah, you should be able to go to connect from Vilnius. Access granted. And this is a very simplified case. For example, because here we are only taking into account multi-factor authentication, but we could add, for example, biometric authentication. We can add passwordless access. We can add a lot of different situations here, like third-party access and so on. So why should we start implementing this type of solutions? Well, 84% of the companies around the world are already embracing cloud-based infrastructure and remote work forces. And out of those, 34 they're making their effort to start creating these zero-trust architectures. And 30% are considering migrating from their legacy solutions to the zero-trust network access frameworks. But as you can see here, there is still a percentage that is in the cloud that is not either considering or already having zero-trust architectures. And those organizations are already vulnerable to attack. But, of course, there can be such thing as too much controls. If, for example, I'm a user that wants to access somewhere, but I need to first ask permission from the administrator, then I need to use my user and password to access the network, and then I need to use multi-factor authentication, which is going to be checked on an authorization database, but also going through an intrusion detection system that will go and ask for a Kubernetes database if it's okay for me to go in or not. At the same time, it's going to be creating some access on the Wi-Fi, which in turn is going to be connecting to a firewall, which in turn is going to be sending me to a server. I mean, this is crazy. And a lot of companies are using this type of solutions because, well, most probably they don't have a CISO or a CTO that is competent in cybersecurity. So they think that the more, the better. But I'm going to roast myself a little bit here because when I was, let's say, 10 years ago, I have been working in the IT industry for like 18 years now, but 10 years ago, I was younger and I was less wise. So I was working as a consultant, as a contractor in a company in which they asked me, hey, I need you to bring your own device. We are not going to give you any device. Okay, perfect. I bring my own personal device, in which I had my Steam account. I have games, I have everything that I use it for entertainment. And I bring it to the IT administrators. They put some software. I'm not going to say brands because I'm going to also roast them a little bit. So that software was not allowing me to access, for example, Task Manager. Every time I tried to open something that was against the policies of the company, they will close it immediately. So, for example, I couldn't play my Steam games. I couldn't install anything. I need to ask permission for my own computer. So what did I did? I practically noticed that this software was running on user space, not on kernel space. So I opened a notepad, wrote something random, click Windows, turn off, and of course a pop-up appeared like, hey, this software is not letting Windows to turn off. Wait a few seconds, I'd click cancel, and then that software was gone because it was in user space. It was turning off. It got the signal, hey, system is going down. Okay, I can turn off. So I could play my games. And that's the reality when you are dealing with IT people. We find a way. We always find a way to get our work done, or in this case, to play our games. And that's one of the bad things about having too much control. When your controls start being too tight, that they are starting to strangle your developers, your resources, well, people will find a way to go around them. So I want to introduce to you sustainable zero trust network access. What does sustainable mean? Well, just as like in the real world, in the nature, we need to create policies to lower carbon emissions, to recycle, to use renewable energy sources in order to keep our environment, the nature environment, healthy for us to thrive. Also, in the cybersecurity environment, we need to use sustainable policies in order for our resources, for our employees to thrive. So first and foremost, the first step into sustainable zero trust network access is define your infrastructure. What do we have? Where do we have it? Where does it connect to? Once you have a whole map of your infrastructure, then you need to start defining your needs. Okay, now I know how my systems interconnect. Now we are talking about users. Where our users need to connect to? Why? When? How? And then you start creating policies based on profiles, based on the needs of every single employee or group of employees. And finally, you define the policies, and you need to always opt in for tailor-made policies rather than out-of-the-box ones. Because one of the big things that I have heard all my career is, hey, we should do this. Why? Because Microsoft is doing it. Well, yeah, but you're a bakery and you're not Microsoft, you know? So yeah, they start putting a lot of restrictions that they don't need. So they start lowering their usability in terms of access and so on and so forth. Of course, there's no such thing as one size fits all. If you go to a blog and say, hey, use this and you will be safe, don't trust that, because every single case is different. You can use some of those as guidelines, that's perfect. But you should never, ever go straight like, I need to do this because he told me. No. If he doesn't know your network, he doesn't know it. And finally, as I was mentioning, frustrating policies end up in looking for workarounds. And that will always happen. That's human nature. So, zero trust network access is just the beginning. The reality is that this is not like the panacea that will cure all illnesses. You still need to keep your network secured by other different means. Network segmentation, as I was mentioning, yeah, of course. Zero trust network access will give you access to something, but that something needs to be segmented. If I have only access to the station or the development environment, I should only be able to access that for a single connection. Because if not, if I have also access to production, a bug or something that I download from the NPM repositories that was poisoned by some ransomware or crypto mining malware will also spread into production. And that shouldn't be the case. And it will be too late if you already realize that it's in production. So again, immutable backups. Your backups should never be able to be modified in any way and by any means. They shouldn't be able to be deleted as it is. They need to go through a series of processes in order to be deleted. They shouldn't be able to be updated, modified by any means, encrypted, and so on and so forth. All your communication needs to be encrypted. That's a must. You need to use at least something that is based on TLS SSL. So for example, if you're using a proxy that is secure that way, should be fine. But depending on how you are connecting, on what you're connecting to what, you should also consider other type of things. For example, site-to-site connections based on IPsec. It's a little bit outdated, but it's still quite good in terms of connecting non-very volatile systems. And encrypted tunnels. They could be either based on VPN protocols, or it could be proprietary protocols. In this case, for example, one of the newest ones that is fairly fast, I will say, is WireGuard. I really recommend it. And so on. We can start talking about firewall service, DNS security, DNS filtering, endpoint compliance. The device has to be a certain operating system, a certain version, has to have these specific things, and so on and so forth. Intrusion detection system, passwordless, and finally, threat prevention and detection. As we were discussing, is one of the cheapest and safest ways of working. So, the takeaways. We need to make sure that we are using sustainable zero trust network access, because this will help in order to get, in order to make ourselves safe and in order to make preparations in order to start building network segmentation, and even going forward, that your whole network is based on zero trust architecture and is micro-segmented. That's one of the best solutions that you can have. And you can use agentless types of solutions when you already have a sustainable zero trust network access policy. You need to keep it up. You need to review it every single quarter at least, if not every single month. You need to adjust it if you think that it should be adjusted, and you need to keep improving, because it's practically weapon war. It's mouse against the cat. You are always going to be chasing each other, hackers and organizations, to keep hackers outside and hackers to get inside. And you should always keep it simple. You should always be the black sheep. Yeah, follow patterns, follow frameworks, but don't copy anyone else. Create your own rules and policies, and don't keep your policies too wide, but also not too tight, in order to keep your organization safe and useful. And that's it from my side. And if you have any questions, feel free to ask. Wait for the microphone.
My question is following. When we are speaking about policies, firewall settings, etc., it means that we have some tools that we purchase, for example, some commercial security services that we set up. We don't create them from scratch. We don't build them from source code, etc. But does it mean that you trust author of those tools? For example, if you purchase some commercial firewalls, why can you trust the company that produced firewall itself?
Well, actually, that's a very good question. You have a lot of options. The reality is that the market is very wide, and not only for products, as you mentioned. If you really want to go down to make yourself to be sure that what you are implementing is what you really need, and that you something that you can trust because you did it yourself. You can go all the way down, for example, to layer 3 and 4 of the OSI model and start implementing stuff like IP tables. That's the very core basic of it. Then you can start using, for example, there's this open source software that is called, organization that is called NTOP. They have DPIs type of solutions, so you can also start implementing it yourself if that's what you are looking for. You can start creating your network segmentation without the need of software that is already built by using kernel models, creating your own kernel models, or modifying, for example, open source projects like WireGuard to make it compatible with TCP, because it's WireGuard by design. There's no such thing as user client. It's rather than UDP connection on both sides. Make it faster, but it's a little bit less secure than TCP connection. You can modify it and start making your own tools. It's completely fine. The main idea here, as I was mentioning in the beginning, Gartner gives you the framework, and some companies take it and start making marketing around it. The thing is that if you understand the framework, if you understand the roots of it, you can create your own cybersecurity by itself. This is not a product pitch. It's something that you can actually do without buying anything.
Thank you.
No problem. Any other question? Nope. Okay, perfect.